Have you ever stopped to think about what really keeps your digital life safe? I mean, it's not just about the antivirus software you install or having a strong password. No, it's way deeper than that. It's an invisible architecture, a fortress built deep inside your devices. And today, we're going to look at the blueprint for that fortress, piece by piece.
So let me just ask you this straight up. We pile everything, our most important data, our apps, our entire digital lives, onto one single foundation. What is it that actually keeps that foundation from just crumbling?
Well, the answer, and the very ground our digital fortress is built on, is the operating system. And that, right there, is where the real battle for security begins.
Yeah, this image really captures it. The OS isn't just another program, it's the bedrock. System security isn't some app you download. It's the set of rules and defenses that are built into the bedrock itself. Its whole job is to enforce the tough policies, like who gets access to what, protecting memory, making sure everything boots up securely. It's the silent guardian for everything running on top of it.
Okay, so every great fortress starts with two things: an unbreakable foundation and some really well-designed gates. And in our digital world, that is exactly where we're going to start building.
Now, this is absolutely crucial. The entire security of the whole system rests on something called the Trusted Computing Base, or TCB. This is the tiny core set of hardware and software. We're talking the kernel, maybe some hardware security modules that we have to trust, no matter what. Because if an attacker compromises the TCB, well, it's game over. The entire fortress just comes tumbling down.
So what guides this all-important TCB? The master plan. In security speak, we call this the reference monitor. And here's the thing, it's not a piece of hardware you can point to. It's an abstract idea. It's the unshakable logic that acts as the system's ultimate gatekeeper.
This slide just nails its job. It's so simple, but so powerful. You've got a subject, that could be you or a program, and it wants to get to an object, like a file. The reference monitor stands right in the middle and makes the call. Is it a yes or is it a no? Every single time. There are no exceptions.
Now, for this master plan to actually work, it has to follow 3 unbreakable rules. First, it can't be bypassed. You can't just sneak around it. Every request has to go through it. Second, it's got to be tamper-proof. An attacker can't be allowed to just waltz in and rewrite the rules. And third, it has to be simple and small enough that we can actually look at it and prove that it's correct.
All right, let's talk about the gates. This table breaks down the 3 main styles of access control. Think of them as different security philosophies. First up is discretionary access control, or DAC. That's kind of like your house. You own it, you decide who gets a key. Then you have the super strict version, mandatory access control, or MAC. This is like a military base. A central authority sets the rules, and that's final. And somewhere in the middle is role-based access control, or RBAC, where your permissions are tied to your job. You're a guard, you get guard access. Simple as that.
Of course, what good are gates if you don't have guards checking IDs? That's authentication. It's just the process of proving you are who you say you are. You do it with something you know, like a password, something you have, like your phone for multi-factor, or something you are, like your fingerprint.
Okay, foundations poured, gates are up. Now it's time to build the internal walls to contain any threats that get inside, and, just as important, to make sure we're not using any faulty or malicious building materials to begin with.
A really smart fortress isn't just one big open space. As you can see on the left, it's got internal walls, different compartments. That way, if an intruder gets into one area, strong walls stop them from getting to the really important stuff. And on the right, you see the other key idea. Every single brick we use has to be certified so we know it wasn't compromised from the start. So these are our digital walls. Virtual memory isolation. That basically gives every single application its own private, padded room, so it can't mess with anybody else. Then there's kernel versus user mode separation. Think of this as an ironclad boundary, a VIP section, just for the super sensitive core of the OS. And you've got things like buffer overflow prevention, which, stops malicious code from spilling out of its designated area and causing chaos. And how do we certify our building materials? Well, we do it with things like Secure Boot, which, every time you turn on your device, makes sure the OS is the real deal. Then there's code signing. Here, the OS basically acts like a building inspector, checking that every critical part has a valid digital signature from a trusted source before it's even allowed to run. It is a constant process of verification. But here's the thing about a fortress. You don't just build it and walk away. Security is a living, breathing process. It requires a permanent, never-ending watch from the towers.
And this leads us to a really critical truth. Building all the defenses is only half the battle. A fortress has to be constantly patrolled, reinforced, and repaired. An unwatched fortress is a vulnerable fortress, plain and simple. That's why this never-ending watch is so incredibly important.
So what does this watch actually do? Well, it has three main duties. First, auditing and monitoring. This is like constantly patrolling the walls, logging every important event so you can spot anything suspicious. Second is system hardening. That's reinforcing the defenses, closing any unused gates, getting rid of anything you don't absolutely need. And third, patch management, which is just constantly repairing any cracks or weaknesses that pop up. An unpatched system is just a crumbling wall waiting to be knocked down.
Okay, construction is finished, the watch is in place. Let's take a step back and take a look at the incredible fortress we've built.
This final blueprint really shows how it all fits together. You can see the bedrock down at the bottom, that's our TCB and the reference monitor. You can see the gates and the guards doing access control. You see the internal walls for memory protection, the integrity checks for all our building materials, and right up top, the watchtower, representing that constant maintenance. Every single part is absolutely essential to the whole structure.
But let's be real for a minute. While this architecture gives us incredible strength, a trusted foundation, strict access control, solid isolation, it is not without its challenges. This stuff is complicated, and it's easy to mess up the configuration. Tighter security often means a hit to performance. And like we just said, the maintenance, it never ever stops.
So if you take away just one thing from all this, let it be this. Real system security is not an accident. It is the deliberate architectural practice of using these deep OS-level tools, all enforced by that tiny trusted core, to build a fundamentally safe environment for everything else we do.
And that kind of brings us to our final thought. We've just walked through the entire blueprint. You get the foundation, the walls, the gates, the watch. So now, as the architect of your own digital security, what keeps you up at night? Where do you think the biggest crack in your fortress wall really is?